Hi guys, today I will discuss totally different topics. Today I will discuss on box plotting. What is box plotting? Where it is used? How it is used? And what is the outlier? So this is a totally different topics and before I going to the data analytics part, that is data science part, I want to confirm you all other my videos or classes will continue as basic mathematics, but along with this new segment I will start from today onwards. I will continue to upload some new topics and some new digital era and upskilling topics to my channel. So today I will discuss on box plotting. What is box plotting and how it is worked. So where it is required? It is required basically during data analytics part. So when you have lots of data and you lots of data from varieties of source, different source, and within this data we want to find out some outliers. What is outliers? Outliers is basically within a data set, some of the data, some of the data is a some of the data is different from this normal range or normal pattern. So we want to filter those unwanted or unwanted data or junk data. So these outliers may be in key in mistake, maybe in process mistake, in processing error, or it's maybe intentionally or unintentionally it will be maybe happened. But what our purpose is that the, with this huge data from data set, we want to predict or analysis some trends, and these outliers actually misguided us. So we want to filter those data. But if the data is small, then we can manually do it. But if it is a huge data, it's a large data set, then manually it is not possible. Then we want to adopt some process. By which process? There is a number of process we can find out the outlier, and one of the process is box plotting. We can another process is normal distribution, Z code. So different process is that. But today I will discuss on box plotting. So this is a basic to find out this outlier. This is a basic, some basic mathematics is there. So what is this? What is the basic mathematics in behind this? So when we get this large set of data, suppose I take the I want to predict some I want to predict or find some outliers. Suppose the price of rice. So Monday it is some price like 40, Tuesday it is say 43, and Saturday is say 49. So this is actually this is a normal trend, although we can find out through this data. So 43, 45, 49, 50, 51, again for 47. So these range we can is a normal pattern. But somehow with this data we suppose there is a value is 2. Maybe the key in mistake in quantity put in the price column. So this data is coming to our trending analysis. So I just explain these things with a example, right? So just let's take an example. So I have taken an example of rice price. So and with this trending analysis I have got some data like and 43, 49 and 2, 51, 51 and 53, 56, 60, 70, 100. So this sort of data I have got. So now from this I want to find the outliers values. Outlier values means if we just go through this data, we can find that 2 is maybe outlier because it's not a normal pattern. It's 43, 49, then 2, 51, 51. So maybe 2 may be outlier we can. But if the data is huge, then how manually is it? It is not manually possible. Then we have to adopt some process. So I will discuss on this process. So in this process, what have to do? We have to do arrange the data. First, arrange the data in from ascending to descending. So what we will do? We will do that. 2 first is smallest number, then is 43, then 49, then 51, then again 51, then again 53, then again 56, then again 60, then 70, and again 100. So this sort of data I have, and this is my data set, right? So to analyze the outlier in our data science or data analytics part, what I have to do, I have to do the 5 data point I have to measure. 5 data points. What are those 5 data points? First data point is the minimum value. First data point is the minimum values. Minimum value is here is 2. And second data point is the maximum values. Max value is 100 here in our data set. And then we have to find out median value. What is the median value? How we will find? In our data set, what we will do, we just count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my 10 numbers of data set. This is the even number. So this is the even number. So what will be the formula of the median? So we just divide. If it is even number data set, then n is equal to 10. N is equal to 10, my number set 10. So we divide by 2. What we will get? With 5. So we will take 5th position value, right? So 1, 2, 3, 4, 5. This is my 5th position value. And then we will take 5 plus 1, that is 6th position value. That is 6th position value. And we club these two and divide that value. That is 51 plus 53 divided by 2. So what will be the answer? My 52. So 52 is my median, right? So 52 is my median. So I have already mentioned to find the outlier. To find the outlier, I need 5 data points. One is the minimum, another is the maximum, another is the median. So 3 data points I have already, and 1, 2, 3. Now we need to find out the fourth data point, that is the Q1 percentile. So what will be the Q1 percentile? Q1 percentile will be the median. Median is the 52. So my first data set. First, now the total data set is 10 numbers data set. So below the median, one is my data set, and above the median another is my data set. Subset. Data set, I can explain it as a subset. So what is my subset? Subset is the first 1, 2, 3, 4, 5. So this is my the first subset, and this is my second subset, right? So from my first subset, what I will do, from my first subset, what I will do, I will again find the median. So in my first subset, now my series is the odd number 1, 2, 3, 4, 5. So in my first subset series is odd number series 5. So how we will find the median? Median formula is, if it is an odd number series, then we divide it, again you divide it by 2, that is 1, 2, 3, 4, 5. That means if it is an odd number, then formula is n plus 1 by 2, that is n plus 1 by 2, right? So its value will be 5 plus 1 by 2, that is 3. 5 plus 1 by 2 is an odd number series 1, 2, 3, 4, 5, and therefore the formula is 1 plus 1 by 2, that is third position value. Third position value is 49. Third position value is 1, 2, 3. So third position value is 49, right? So this is my Q1. My fourth data point is Q1 is 49. So Q1 is a quarter 1 percentile. Quarter 1 percentile I have to find out. So how will find out? I will find out Q1 percentile. Q1 is 49. And my fifth data point is Q3. At the same method we will apply here 1, 2, 3, 4, 5. Therefore n plus 1 by 2, that is 3. So 1, 2, 3. Third position value is 60. So my Q3 percentile is 60. Okay. So these are the 5 data points. I have got 5 data points, and with this 5 data point, we will apply this. With applying these 5 data points, we will get the outlier. How we find the outlier? I will go through it. Now what I will do? I have to find out the interquartile range. What is this interquartile range? IQR, interquartile range. What is the formula of IQR? IQR formula is Q3 minus Q1, right? Q3 minus Q1. What is the value of Q3? Q3 is 60. What is the value of Q1? Q1 value is 49. Therefore, IQR is 11. Right? IQR is 11. Now I have to find out the interquartile range. That is interquartile range IQR I have got. So for box plotting or find out the outlier, what will be my range? What will be my range? My range is, formula is very simple. What is the formula? Formula is Q1, my range will be Q1 minus 1.5 into IQR, comma Q3 plus 1.5 into IQR, right? So below this lower range will be the outlier. Above this value or greater value will be the outlier. What will be the value? Q1 is the value is 49. right? So Q1 when value is 49 and minus 1.5 into 11, my IQR is 11, and Q3 is 60. Q3 is 60 plus 1.5 into IQR 11. That means 1.5 11 and 16.5. That means this value is 49 minus 16.5 and 60 plus 16.5. 60.60.5. So 7 means 2, 17 means 2, 1, 32, 32.5, 32.5, and this is 76.5. This is my 76.5 and this is my 32.5, right? So below 32.5 is my outlier and above 76.5 is my outlier. If in my data set, if any value below this 32.5, this is my outlier, and above my 76.5 is outlier, right? Clear? No confusion. Now we just put it in a graphical manner, the data representation part. Now I come to in data representation. This is a concept or statistical formula by which we can find out my outlier. But you don't need to worry because now you may think that, so I have to calculate this sort of mathematics or this sort of calculation. No need to do that. In your language, in your programming language like Python, in your Python language, if you use the library like pandas and numpy, then you will get the already UDF function, user defined function already built in there, and we may use that what-ile is the function. In just put the value is 0.25, then you will get the Q1. You will put the value 0.50, then you will get median. If you put the value 0.75, then you will get the Q3. So now you may ask that, then why we have learned this? It's very simple. We just use the formula and pass the parameter, then we will get the result. So what is the need to learn such complex things or such easiest thing, whatever you may think that? But why I have told this, or why I have told this, because you may use that function, UDF function, no issues. You can get the correct result. But what is the concept? Concepts need to clear. That is why how we find the Q1, how you find the Q3, this Q3, you need to know. That is why I have discussed it. Now, in this formula or in this mathematics, how I represent the data, how I found the outlier. So this is my next step. I just erase this and then I put this in. So now I am doing the box plotting. So what you have to do, you just suppose in graphical manner, the 0, it's 10, it's 20, it's 30, it's 40, it's 50, it's 60, it's 70, it's 80, it's 90, and it's 100. Right? So first my IQR. What is my IQR? IQR is, you get the 49 and 60. Right? Interquartile range is a very important part in your outlier calculation. So that is 49 is my minimum and 60 is my maximum interquartile. So 49, that means here, and from 49 to 60. So that means here. This is my 49 and 16. What is the median value? Median value is 52. Median value is 52. So median value is 52. That means here. This is my median, right? This is my median. This is my lower interquartile rate, and this is my upper interquartile rate. That is 49, 52, 60. This is my box plotting. Now, what I have to do? I have to do now the minimum value. Minimum value is 2, but 32.5 is my range. So below the 35 is the outlier. So 2 value is the outlier. Should we can mention it asterisk. So 2 is my outlier, right? So we can take the minimum value is 43. So 43 means here is the 43, right? This is my 43 and 60, 70 is my maximum range, because beyond 76 is my outlier. So 100 is also an outlier. So we can take asterisk and make it 100. So this is my outlier. And 76.7 is my above range. So we can take it. This is my 70. So this is my box plotting. This is my box plotting, and we call this is a whisker. And this is called outlier. So in my data set, 2 and 100 is the outlier. So maybe keying, maybe processing in process, during processing the value is wrong, or during typing typographic mistake. So it's price, instead of price, quantity we have put, or data entry operator put the quantity. So during the calculation, during the price trending analysis, or when we plotting in the graph on BI, it will may lead the wrong information. That is why we have to find out the outlier first. What are the wrong values? We have to eliminate those values, or we eliminate those set and again put to the business or system wherever is possible to correct the data. And again we take this data and put this value. So this is the concept of box plotting and find the outlier. So one of the method to find out the outlier. So this is the whole sort of thing. So what we have learned? We have learned number of things in this video. First of all, is required. Where is required? Is required during the data processing, data analysis, and the data science part. Right? During the data science, very beginning of the data science, very beginning part of the data science, there is a data analysis part where this process is required. Where is actual in real life example is that suppose you have got the lots of data in price like rice price analysis, in day by day analysis, or quarter wise analysis, or monthly analysis. You want to analyze the predict some analytical values, or put it in the graphical manners in BI or click view or ClickSense, whatever in your tool. You can put feed in this data. So if you feed in this data in the your tool, it will give you the wrong information. So clean the data. Data messaging is required. So during the data messaging, this process is required. So, and we can do it in tools, or we can do it in Python. In Python in language, it is very simple. It is already inbuilt defined function, so we can use it. But please know that the concept. So this is with the concept. The concept is that there is number of terminologies you have to know. The knowing part is that What is the Q1? Q1 percentiles means Q1 percentile is mean this is a lower quadrant. If it is a 25%, matlab 20, below 25%, 25 percentiles mean 25% records in this set of data, in this total set of data, right? Sure. This is the formula, or this is the method box plotting, and you can easily find out this box plotting. So what is the five for box plotting or outlier find out? Five data points we have required. One is the maximum, another the minimum, and there's a median, and another is the Q1, and another is Q3, right? So these are five data points, and with these five data points, we can calculate the next step is IQR, interquartile range we have to calculate, and post interquartile range calculation. There is a formula. That is formula is the lower part in my valid data set. In my valid data set range is that valid is the Q1 minus 1.5 into IQR, comma Q3 plus 1.5 into IQR. With this range, my data is valid, and other than that, these will be the outliers. So we can eliminate that data. This is the process, very simple process. It's a class 1, class 5, 6 mathematics, so no complexity in between is there. So it's very simple. Thank you, enjoy, and do the programming, right? Thank you.